In a section of this factory, we have a compressor that provides compressed air necessary for pneumatic operations. This compressor has this heavy-duty motor, and we've placed a fan here to keep the motor from overheating. We want to write a program so that when this switch is pressed, both the motor and fan will run. If we press the same switch again, we want both of them to stop. In other words, we want to use the same switch to both start the components and stop them. This single switch configuration is used in a lot of different industrial applications. The single switch is much like the power button on your remote control. You press the button once, and the component turns on. You press the same button again, and the component turns off. Let's write a program that will do the same thing. Here, we have an input connected to IOO and two outputs addressed as Q40 and Q41 in order. We've also filled in the symbol table to reflect the controls that we have. To start the programming, we're going to add two networks here and insert an SR flip-flop instruction in both networks. Assign MOO to the first SR and MO1 to the second SR. We'll add an open contact in each of the set and reset inputs of the first flip-flop and address both of them to IOO. In the second network, we'll do the exact same, except we'll use close contacts instead of open, again assigning them to IOO. In the first flip-flop, insert a close contact in the set input and an open contact in the reset input, assigning MO1 to both of those contacts. In the output, let's add two coils and assign the fan and the motor to them. In the second flip-flop, we'll add two contacts but invert them. So we'll add the open in the set and the closed in the reset. These contacts will be assigned the address MOO. Now, let's save, download, and put the system in online mode. Here, we see that MO1 is not activated in the second network, so that means that this closed contact here is energized in the first network. So now, if we press the switch once, both the fan and motor will run. After pressing the switch, we see that MO1 is activated, so its open contact here is energized. If we press the switch again, the signal will pass from here and turn off the outputs. A much more simple way to handle this situation would be to use an edge detector instruction. Let's look at the next lesson to write this same functionality using edge detectors instead.